Today's lesson is on slope and the slope of a line. So slope is the rate of change between any 2 points on a line. We can look at slope and we can say it's like the change in y, which is like how much is it changing on your y-axis from one point to another, over the change in x. How much is it changing on your x-axis from the one point to the other? So if you look up here, slope is going to be defined as your change in y, which is your rise, over your change in x, which is your run. So a lot of times we say it's delta y, which that's the Greek symbol for delta, and it means change in, over delta x. So if we look down here and we actually look at a graph and we have these 2 points on the graph, there's a couple different ways you can go about finding the slope of a line. First way is to actually literally count. We have 2 different types of slopes here. If you're looking at the difference between number 1 and number 2, in number 1, anytime you read a graph, you're going to read it left to right. So if you look at this graph and you notice that it is going down, okay, as you read it left to right. In number 2, you'll notice that your graph is going up. What this means is that in number 1, you're going to have a negative slope. In number 2, you're going to have a positive slope. So kind of keep that in mind as you're finding your rise to your run, because I always say that we rise one way. You can always you rise up, but you can run left and right. So if you're rising up, that's positive. But if you're going to run right, think about right on a number line, it's going to be kind of positive. If you're going to run left on the number line, it's going to be negative. So when we look at number 1, we're saying, all right, I'm going to go from this point here to this point here. So I'm going to count vertical rise, so change in y, over horizontal run, change in x. So I'm going to go up 1, okay? So the vertical rise was 1, and now I'm running 1, 2, 3, 4, 5. I'm running 5, but I'm running 5 to the left. So that is negative. So the slope in number 1 here is going to be negative 1/5. Slope we have is represented by the letter m. So slope is equal to negative 1/5 in this problem. And it's not necessarily the 5 that's negative or the 1 that's negative. It's that entire slope. So you can put that negative sign in the numerator or the denominator. So looking at number 2 then, if you're going to go from this point to this point here, change in y over change in x. So vertical rise, so 1, 2. Okay, so slope is 2, the ratio of 2 to 1, 2, 3, 4, 5, 6, 2 to 6. So this has a positive slope because I rose positively and then I ran right positively. Now we always like to reduce this. So the slope of this problem is actually going to be 1 to 3. So that's one way to kind of look at it. We also have in numbers 4 and 5 here, we have 2 different types of slopes. In number 4, we have a horizontal line, and then in number 5, we have a vertical line. So to figure out the slope of these, you still think of rise to run. So you start with one point and go to the other. It doesn't matter which point you start with. So I'm going to go here to here. So my slope, change in y over change in x, delta y over delta x. So rise, I'm not rising any. So that's 0. But running, I'm going to run 1, 2, 3, 4, 5, 6, 7. So the slope of a horizontal line is actually 0. So let's take a look at the next one. Change in y over change in x. So we're going to go from this point here to this point here. So slope equals change in y, so rise 1, 2, 3, 4, over change in x. Okay, I'm running none. I'm not running any. So if you look at this though, okay, in number 4, it was 0 over 7, which is 0. But in number 5 here, this vertical line, it's 4 over 0. And we know 0 cannot be in your denominator. So the slope of a vertical line is considered undefined. Okay, because you have no change in your x-axis. So you can use this information and you can actually draw a line from that. So if you look at number 6, it says negative 2, 4 with a slope of 2. So 2 has It's always a ratio. If your slope looks like a whole number or an integer, you can always put it over 1. So it's a rise of 2, a run of 1. So here, if we're going to draw this line using this slope, I'm going to go negative 2 and then 4. 1, 2, 3, 4. So that's right here. And if I want to have a slope of 2, a slope is a constant rate of change. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. You can plot an infinite amount of points on this line if you're just given a point and a slope. So play connect the dots. There is a supposedly straight line for the slope of a line that goes through negative 2, 4 that has a slope of 2. If you want to pause the video and try number 7 and 8, you may. So you'll notice in number 7, this one has a slope of negative 1. So I started here at 1, 3, and put it in a different color. And then I said, all right, well, I'm going to, well, I went down for my negative aspect, and then right 1. So down 1, right 1, down 1, right 1, down 1, right 1. Or I could have gone up 1, left 1 for the negative piece. Up 1, left 1, up 1, left 1, and plotted the points that way. So that's one way to find slope. Another way is to actually use the formula. Change in y over change in x right here. So the formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And when you're doing this, it really doesn't matter which ordered pair you call coordinate 1 or which ordered pair you call coordinate 2. I'm going to show you with 2 of these that you can do it either way. So in number 1, I'm going to just call this coordinate 1 and this coordinate 2. So if I'm following my y sub 2 minus y sub 1, so that's the y value of the second coordinate. This is your x value of the second coordinate. This one's your x value of the first coordinate. This one's your y value of the first coordinate. So y sub 2 is going to be this one right here, which is 6. So 6 minus y sub 1. So change in y. Change on your y-axis, which is 3, over x sub 2, which is this value here, 2, minus x sub 1. So change. Whenever you do the change in two values, it's always subtraction. So you have 6 minus 3 over 2 minus negative 1. So 6 minus 3, that's going to give you 3. 2 minus negative 1, that's going to give you 3 again. So your slope in this problem is going to be 1. So it doesn't matter which one we called value 1 versus value 2. I'm going to show you with the same exact problem that even if I say, let's just clear all this up. Even if I say that this first coordinate is going to be my sub 2's. So this is x sub 2, y sub 2. This would be x sub 1, y sub 1. I'm still going to do change in y's over change in x. So my change in y's, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You'll notice that in my numerator here, my change in y, I have 3 minus 6, which gives me a negative, I almost wrote negative 6, a negative 3 this time, over, but then look at the denominator, negative 1 minus 3, or minus 2, gives me that negative 3 again. So a negative 3 over negative 3 is equal to 1. The slope the first time was 1, because it came out as 3 over 3. This time, even though it's negative 3 over negative 3, it's still a slope of 1. So it really doesn't matter which one you call your y sub 2, or your first ordered pair versus your second ordered pair. So if you take a look at the rest of these problems here, you can go through. There's 2 that I want to draw your attention to, and that's numbers 5 and 6. Sometimes you don't even have to do the work. If you see a number 5, you'll notice your y values are the same. If you look at number 6, you'll notice your x values are the same. One of those is a horizontal line, one of those is a vertical line. So if you're doing your change in y, so negative 1 minus negative 1, that gives you 0. So you're going to get 0 over whatever value, it doesn't matter, whatever your x value is. Here, if you do change in y over change in x, you're going to get your y value over the 0. So if your x values are the same in number 6, like in this one, that is a vertical line. Okay? If your y values are the same, that is a horizontal line. Every single solitary time. Horizontal. Almost forgot the T. Okay, so you can figure slope a couple different ways. You can literally go rise over run, change in y over change in x, and count. Or you can use a formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you're simply given the ordered pairs in a table format, just choose any two of them. So choose this one and this one. It really doesn't matter. So that ordered pair is 3, negative 2. This ordered pair is 6, negative 7. And because these are linear functions, they fall on a line. Every single solitary ratio of change in y to change in x is going to be the same because they have that same slope. So slope is extremely important to understand and know, especially when we start talking about linear equations and graphing equations and things like that. So always remember, change in y over change in x, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1.